Joao, who is the lead developer of MicroSTAMP, and Gabriel, who is the front-end developer of MicroSTAMP. Both have Bachelors of Computer Science from Federal University of Alfenas in Brazil. Welcome.
Thank you. Thank you, John. 1 second. Let's start. Okay. Hello everyone. My name is Gabriel Piva, and today I will present. 1 second. Okay. Now I think it's okay. Greetings, everyone. My name is Gabriel Piva Pereira, and today I will present MicroSTAMP, our free and open source STPA tool developed with a microservices architecture. So last year, our team presented MicroSTAMP for the first time at this workshop, and this year we will show how the tool has evolved since then, and guide you through a hands-on demonstration of its main features. So our focus today will be in how the tool has grown since last year, the advantages of its microservice architecture, and the main features. Then we will show you the tool in practice, and finally share you how you can join and contribute. So MicroSTAMP is a free and open source tool that supports the STPA technique. It was built on a microservice architecture, meaning that each STPA step is implemented as an independent service, rethinking how STPA tools are usually designed as monolithic architectures. This design is intended to improve MicroSTAMP's modularity, scalability, and flexibility. One important point is that MicroSTAMP was designed as a local-first tool. Even though it's a web-based system, the idea is that the analysts or organizations will run it in their own local environment, usually via Docker. This guarantees security, privacy, and control over the analysis data. We also will use a local version for today's demo. So last year, MicroSTAMP supported the first 3 steps of STPA. Based on your feedback, we expanded the tool. Now we also support the step 4 with 2 approaches for the step. The first one we called handbook approach. That is the traditional way to identify the loss scenarios. And the other one is the formal approach that is based on John Thomas' video formally developing loss scenarios that was published last year. We also improved the usability of the tool with better export features, preloaded example analysis, and refinements in the unified interface. So about the architecture of the MicroSTAMP, MicroSTAMP is composed of independent microservices, one for each STPA step, and supporting services such as an API gateway, a service registry, and an authorization server. Each step has its own database, keeping bounded context and ensuring traceability. This architecture makes the tool modular, scalable, and flexible. You can use MicroSTAMP as a complete tool for STPA analysis, or just the APIs for specific steps. This makes it easier for other teams to integrate our services into their own tools while keeping analysis consistent across steps. So today, MicroSTAMP provides complete STPA support, including 2 approaches for the step 4 that we'll show more in detail in the demonstration. We also provide a unified interface that integrates all microservices, the microservices APIs for each step for individual use or integration, preloaded example analysis for quick testing, advanced export features with navigation across the steps, and secure access through auth2 and OpenID protocols. But now, instead of just describing the features, let's move on and actually see them in action in a live demonstration. So I will open here the tool. I think it's working. Right. So here, I'm in the home page of MicroSTAMP, and I'm logged in as a guest user that has our preloaded example analysis. Here, I can access all the analysis of this user, and I can access here, create new analysis, and I can access the main page of each analysis here by clicking on them. And here I have the main information, the main page of each analysis. Here in this demonstration, we use this system, that is the insulin pump with continuous glucose monitor, for demonstrate the tool. Here we have the information about the analysis, the system. We can add a reference image here, and up here we can navigate across all the steps and actually do the analysis. So as we presented last year, the first 3 steps, this presentation will focus more on the step 4, which is new, but we will go quicker in the first 3 steps. But to start, I will go here in the define the purpose of the analysis step, and here we have all the entities and the artifacts related to the first step. And we have here the system goals, the assumptions, losses, hazards, and system safety constraints to this analysis, and we can manage all these entities here. We have the step 2 here, is the same as the last one. We have the entities related to the model the contour structure step here, and we can add new components, add connections between the components that we identified, and we also have the contour structure image here that we can add for reference for the contour structure that we are modeling here. And within each connection between components, we also can add control actions, interactions as control actions, feedback within the connections. And for each component, we also can define responsibilities for the component and add the variables and the related states for each component here. Going to the step 3. For the step 3, first we need to choose which control action that we will analyze to identify unsafe control actions. Here I will choose the insulin pump component and the pump insulin control action. And by continuing here, I will be redirected here to the page where we have all the unsafe control actions that we already identified for this control action here, the pump insulin example. Here I have like 7 unsafe control actions, and we also have the associated controller constraints that is automatically generated when we identify a new unsafe control action. And to identify new unsafe control actions, we can access the page here, and here we have the context table page and the rules page here to identify new unsafe control actions. Here we have the context table related to this control action here, and we can go through the table and manually identify new unsafe control actions by clicking here and adding a new unsafe control action. And we can also create rules here and applying the rules in the table to automatically identify the related unsafe control actions. Now we're moving to the step 4, and with the step 4, we have the 2 approaches. So first, we can choose which approach that we want to use. I will show first here the STP handbook approach. So here in this page, we have the traditional way, the handbook approach that we call. And here we have a list of the identified loss scenarios that we identified for this analysis. And you can create new ones here, adding a code, a list of unsafe control actions, or one unsafe control action here for reference, a scenario, associated causal factor, a recommendation, and a rationale. And below here, we can filter the scenarios here by selecting one unsafe control action and see the loss scenarios related to that unsafe control action, as here in the example. This is the handbook approach for identifying the loss scenarios, and I will go now for the formal approach for identifying loss scenarios. The formal approach, we first need to select which unsafe control action we want to analyze. So here you choose the first one here, that is insulin pump does not provide pump insulin when glucose level is high. Continuing here, we have the main page here for the formal approach. All this content here is based on John Thomas' formally developing loss scenarios video, and is our interpretation of how to apply the formal approach in our tool. So here in this page, we have the page organized in 4 containers, and each container represents a class from the formal approach. And we also have a reference image for all the classes here, the class 1, the unsafe controller behavior, unsafe feedback path, the class 3, and the class 4. And inside each container, we have the 4 activities for that related class. So for the first class here, we have the 4 activities for this class. They identify high-level scenarios, and the high-level scenarios are automatically generated by the tool using the unsafe control action that we are analyzing. And from the high-level scenarios, we can identify the high-level solutions here by editing them here. We can identify the refined scenarios. And for the refined scenarios, we have here a list of the common causes from the formal approach. We have also a image of reference here for seeing the common causes. And by choosing the common causes here, we have the description of the common cause and the list of templates related to that common cause, and the list and with the pre-filled values related to the unsafe contraction that we are analyzing. So I can choose a template here, it will be loaded here in the editor, and I can edit here and like change everything, fill the blank spaces here, and create the refined scenarios here following the formal approach. And also we can identify the refined solutions here by selecting the related refined scenario that we are creating a solution and creating the solution here. So this is the way that we implement here the formal approach for identifying loss scenarios. And this page, we also can organize the page as by choosing organizing the containers by activity and not by class. So here each container is representing a class, but if you want to use the containers by activity, we can choose here, and each container changes to the activity. So here the high level scenarios, and inside each container we can go and see the four classes within each container, and the same for the other ones. So this is the four steps that we did. I will go back really quick here and show you how you can export the analysis that we did. So I can have here this button to export the analysis. I will show here the PDF that I already downloaded. This is a PDF that the tool generates, and it has all the table of contents here, all with hyperlinks to click and access the whole document here. We have the analysis information, we have the system goals, assumptions from step 1 here, and we have the hyperlinks. If we click, for example, in hazard tree here, we will be redirected to the hazard tree here. And it's the same for all the steps. We have all the images, all the unsafe contractions identified, and the two approaches for the step 4. So this is the tool. I will go back here to the presentation. Just 1 second. Here, let me open again. Okay. Okay, so in conclusion, MicroStamp has evolved since last year from supporting only part of STPA to now providing full support for all 4 steps. It can be used as a complete tool, as I already showed, for STPA analysis, but it also offers the flexibility of integration through its microservices architecture. MicroStamp is a free and open source evolving project, and we invite the community to explore, test, and help us improve MicroStamp even further. You can find all the source code in our GitHub organization. The repository includes detailed step-by-step instructions on how to install and run MicroStamp locally, so you can easily download and start exploring the tool yourself. Once you try it, we welcome all kinds of contributions, whether it's reporting bugs, suggesting improvements, or developing new features. This is a community-driven project, and we'll be glad to have you join us in making MicroStamp even better. So thank you very much for your attention, and thanks again to the MIT STAMP workshop organizers for this opportunity and having us again to show how we improved MicroStamps since last workshop. And now we're open for questions.
Great, thank you. It's from looking at the chat during your talk, there's a lot of interest in this tool. Everyone, please feel free to submit questions in the Q&A panel. The first question here is the control structure modeled automatically based on previous inputs, or do you manually draw it in the tool?
No, you have to add a reference image to your model, the control structure here. What you can do in the tool is add the components, add the connections, add the interactions within the connections, but this control structure here is an image that I uploaded for reference for the components and connections that I identified earlier for the system.
I see. So there's no drawing part of the tool.
No.
You just add an image yourself.
Yes.
Not yet, John, but this is on our backlog for the future. But for now, you need to manually input to all the necessary components and connections in the step 2 interface to create the control structure.
Got it. Yeah, and I'm not complaining. I'm just trying to make sure I understand. That's all. Great. Another question, in the tool, does it have a database with a list of equipment or bill of materials that you can select, or would it be something you enter manually?
In MicroStamp, we use a framework called Spring Build, built on Java programming language. And that framework gives us the flexibility to choose basically what database you want to use. So yes, you can use a locally created database, for instance, in the user machine, or you can easily change and use a virtual network hosted database, for instance. That's some flexibility that Spring Boot gives to MicroStamp.
Got it. There's some concern with people about entering sensitive information into the tool. It looks like on the screen this is running locally. Is this something that would run on their own machine so it does not send data to a third party, or is it cloud-based?
That's a great question. And MicroStamp's main focus is to be a free and open source tool, so you can use it easily deployed in your local environment to harvesting your local data in your network, or yes, you can opt to use in a local published version or your machine or in your network of your company. That's your call. You can use it as you want.
Great. I'm just scanning for, there's a lot of questions. I'm just trying to read a couple. Are there any templates based on the tool, or could you in the future define some templates to help people get started?
Sure. Actually, when you first install and download MicroStamp, it comes with a set of preloaded analysis. Then that's what Gabriel is showing on the screen, that are used as examples to show how the tool works. So we have modeled all 10 control structures of the STPA handbook appendices, and also an example of the insulin pump with glucose monitor analysis that Piva presented so far, and another example of a role-based access control. And for now, that's what analysis we have so far as examples. But sure, in the future, we plan to add some more.
Got it. There's another comment about intentional sharing of results where we may need to share to communicate with other folks on the team. Is there a way to export or share like project data between maybe multiple computers so you can facilitate a team who's doing SDPA together?
Yeah, sure. Since MicroStamp is based on a microservices architecture, it exposes what we call APIs as a manner to easily integrate with other systems. So in the way that Piva is showing the screen, this analysis displayed in the user interface, they can easily be retrieved via API calls and integrated with another system. So you can export, for instance, the glucose analysis as PDF, but also as a JSON and integrated with other teams' work.
Great. There's a huge number of questions that have come in on this talk, more than most of the talks. So but we're out of time. Let me invite you guys to the Q&A panel where you can type your answers if you have a few moments, and thank you very much.
Thank you so much,
Thank
John.
you.